equals 3, because 50% is in the middle of this bottom axis, and it's just at the top of the guessing range here. Still, the blue line is the highest. So that's corresponds common sense kind of reaction to the marking scheme, that if you're really not sure about it, you're crazy to do anything but put down C equals 1, and you'd be dumb to put down no reply if you think you might possibly get a mark by getting it right. Also, the other equally obvious thing is that if you're very sure you're getting it right, I'll just erase these marks and start up here. If you're really sure that you're getting it right, then you can you'd be very dumb to do anything other than put C equals 3 here, because you're always going to get 3 marks if you're certain you're going to get it right. But if you're, say, 90% sure you're getting it right, if you're down in this kind of area, you're still better off to, didn't seem to be able to make the thing happen there. If you're about 90% likely to be getting it right, you're still better off. You've got to go down to below 80% before the risk of getting a -6 really exceeds the benefit, the likely benefit of the C equals 3 getting it right. These 3 lines here that show for C equals 1, C equals 2, C equals 3, there's a zone of the likelihood of getting it right for which each of these is actually the highest graph here. If you're in between 60 and 80% right, then you're best off to go for C equals 2. You're marginally better than C equals 3 or than C equals 1 in that range. But as I said, the main distinction that students will usually be making is between high likelihood of getting it right, fairly sure, or pretty unsure, the red line or the blue line. So they are always, this kind of mark scheme ensures that they're always motivated to be honest about their likelihood of getting it right. There's no point in trying to pretend that you know more than you do. If you put C equals 3 down for questions where you actually are not very sure, then you are going to be you're going to be down in that kind of area. You're going to be down in this kind of area again. So pretending that you're confident is completely dumb. Going for the option that Geoffrey discussed a little bit of always going for C equals 1 because you don't like the idea of getting negative marks, that means you're always going to be on that blue line, somewhere in that zone. You're never going to do very well because you're missing out on these things that if you could tell which were the reliable answers, you'd be getting those marks for most of those questions. On average, you'd be benefiting much more. So, going to unclutter this. This is a mathematical way, if you like, of expressing what is fairly obvious in looking at the straightforward marking scheme, that it's to your benefit to correctly identify those questions that are more reliable and those questions that are less reliable. One of the really things that is somewhat novel in a way to the students about this is that using the certainty-based marking scheme, it rewards them for acknowledging they're unsure about something. If you acknowledge that you're unsure about something, you put down C equals 1 because you know that there's a risk of getting it wrong, then there's a benefit to you in doing that. It's very unusual for students to see a benefit in saying they're unsure about something. This oughtn't to be so. If you're reading an essay by a student and they're writing things down there that they're really not very sure about, whether they've got the names or the facts right about the thing that they're writing about, it's actually entirely sensible for them to say they're unsure about these things. It's very disturbing when I've asked students sometimes what they do in writing an essay if they find that they're putting things down that they're unsure about. They will usually say, oh, I would never admit to this. I would never put a question mark in the margin as I'm writing, because the person reading it, the examiner, might think that that I didn't know it when I hope it's right. Well, of course, they hope it's right. Otherwise, they wouldn't have put it down. But if it is right, and the examiner sees that they've said they're not completely sure about it, then they're not about this against the student. Whereas if it's wrong and the student has said they're not sure it's right, this is actually going to relieve the way in which it counts against them quite a lot. It's a part of life, as it were, that it's really very important to admit you're unsure about something if you genuinely are unsure about it. And students in conventional approaches to assessment, they aren't aware of this, and they're not rewarded for acknowledging that they're unsure about it. The certainty-based marking system is doing that. It is rewarding you for acknowledging that you're unsure about things. It's rewarding you for going onto the blue line here if, in fact, you're only somewhat above guessing, if you have partial knowledge about the thing. I should ask whether he feels I've addressed some of the issues he was bringing up, or whether other people have issues about this, because it's very important, this business of understanding when you're actually sensible to use the different certainty levels.
Yes, if anyone would like to ask a question or make a comment, please just click the little hand symbol so we know the order to let you speak. Okay, Tony, I'll just keep going. Oh, hang on, sorry. It looks like Clara. Clara, would you like to take the microphone?
Having little conversations about linking things up while in the learning on the text boxes. Okay, so is somebody wanting to, is Clara going to say something, or is the microphone indeed?
Yes, Clara, you clicking the talk button if you are talking, or if you're on a PC, the control button?
She says yes. Hi, my question in the text I can see. But the role of marking in summative assessment, Clara is asking in the text box there. Yes, this is something I'd like to get on to. Indeed, it'll come up a little bit in the next slide here, because I've talked about how it's best to use C equals 3 here when you are fairly sure, and it's best to use C equals 1 when you're not. One of the questions one can ask is how well do students actually do this? How well do they discriminate between the probabilities that they're getting different questions right? And this is something that I'll show in this slide. I will talk about use of marking and assessment if we have time. How are we doing for time here? We've gone on for an hour. God. Okay. So, looking at the data for the use of for certainty-based marking by the students here, there are two graphs here. The one on the left is for online self-test experience with certainty-based marking, and you can see that the questions that students have marked at C equals 1 here, they've only got about, on average, 56% of them right or something like that. The ones that they've marked, that they've indicated C equals 3 for, they've got on average about 83% of them right. In the correct ones, on average, more than 80% for the C equals 3 here. When you look at data in exams, because we use this for 5 years in summative exams at the end of the year here, you see that it's on the right here, the data is similarly spread out. The data for C equals 3 is a higher percentage that they've got right at C equals 3, and that may be attributable partly to their being rather more wary of going for C equals 3, more of the risk of a negative mark in the exam. It may also be simply because they have fewer misconceptions. There are fewer -6s here in the exam because they actually know more by the time it's got to the exam. So the main point I want to make here is simply that the students are very good at discriminating between these different degrees of reliability of different questions and using the system on average quite optimally. Another point that one could make here, the data just separates males and females. In the exam data, there's absolutely no difference between males and females here. In the online data, there are slight, but certainly not statistically significant differences here. It's sometimes something that people bring up, the idea that females in psychological tests are sometimes less confident about their performance for a given level of accuracy than males are. If that's true, and it may well be true for people starting out with a certainty assessment system like this, if it's true initially, it certainly seems to, for a difference between males and females, it certainly seems to have disappeared after they had some experience, and it's not something to worry about at all there. Just to go on to the next slide here, because I should speed up a little bit, I think. This business of virtual learning environments and such like, the lab system, it's been developed specifically for this purpose in science and medicine and basic maths to an extent for CBM. But people would often think that they would like to use self-tests and certainty-based marking directly in a virtual learning environment. You can certainly use self-tests in a virtual learning environment, of course, but I'd like to go through some of the features that have been actually incorporated into LAP as things to improve the efficiency of it. One is CBM itself, and you put CBM code into Moodle, but and this is something that I've written the code for in order to be able to help people who already are deeply into Moodle to experience it. It's a bit of a tricky business, always chasing the way that Moodle code is changing. But we have Moodle for 1.9 and 2.0, which works fine, and people can use that. But there are many other things here. The immediate feedback here, which I mentioned briefly earlier on, most virtual learning environments in running quizzes, when you answer a question, this has to send information back to the server, and then the server sends information back to your computer. And the delays in this, which are not necessarily very long, but even a delay of a few seconds can actually be quite disruptive in providing the quick feedback. I use JavaScript, which means that the computations are all done in the student's own computer, so that the response is essentially instantaneous. You wouldn't want to do this for a high-stakes on a virtual environment, which is why they often do it in the other way, because it's fundamentally it's possible for a student to devise a computer program that would tell them what all the right answers were, so that they could actually put the right answers in consistently in an exam test if you use JavaScript. That's not a worry if you're doing self-tests, because there's no point at all in a student using a crib in order to put in all the right answers, because the whole thing is just for their benefit, and they won't learn from their own mistakes if they do that. Another thing is I showed you these self-tests where the students choose the questions that they're looking at, to make be a small proportion of the questions in an entire file. The marks are presented to the student in relation to the questions they've chosen. So they get 80% perhaps right of the 20 questions that they worked on, and that 80% may be only 8% of the total number of questions in the file. So it's very important to present the marks in a sensible kind of way to the students. The comment and discussion facilities I talked about a bit. It's good to have them relate to specific questions, and the system is designed to maximize the advantage of that. There's an issue of which is in medicine particularly is a bit of a problem, that LAPT uses a system where you can group questions with common stems very efficiently, and you may have 5 or more questions which are basically based on the same presentation of material. This isn't a structure that is actually very easily incorporated in some virtual learning